evening and welcome to the Madison DX Club's June feature program. Tonight, we're very pleased to have Rob Sherwood, NC0B from Sherwood Engineering, a returning speaker to our club, speak on helpful test equipment and tools in the ham shack. What test equipment do you really need to optimize your station? So Rob, we're looking forward to learning how to use those oscilloscopes and all those other neat things that, quite honestly, in the surplus market are becoming quite affordable and much more easy to obtain these days. So Rob, program's yours.
Okay, so I'm going to share my screen here, and I want to be sure that it's advancing. Okay, so there's the, when I go to slide 2, did that switch?
It did.
Okay, all right, so thank you very much. Glad to be back after just a little less than a year. Before I talked about transceiver performance, but this is new to me to be able to give a presentation on test equipment. So what do you really need? And that's going to depend on your inners. Let me move this, you guys' pictures off to the side. So here's a bunch of subjects. I'm not going to read them here because we're going to talk about each one individually, but you can see there's a lot of things that we may want to have in your shack, or maybe not. It depends on what your inners are and what your requirements are for a given project. So I'd say one thing we need to know more about is how do we have a clean signal on sideband? And also we can mention CW, you're going to come across that in a moment. If you're just running barefoot, you probably don't have much to adjust except your ALC level, and you just don't want it buried. I know on my ICOM, it's run about 3rd scale or something like that. But if you're driving a linear, now I think back, I built my first linear while I was in college. It had a single 3500Z, and I have no idea how I decided how to adjust my drive level. I mean, it had a plate meter and a grid meter, and I probably said, well, maybe half scale, who knows? So hopefully today we've got a lot of options to have a better idea where to adjust the drive level. And I would say a monitor scope would be very important to have. I admit that most people probably don't, but the old Heathkit or the Kenwood monitor scopes, if they still work, they're great. They're easy to hook up. They got an RF in and an RF out, and off you go. But modern scopes are affordable, and I mean modern might be 30 years ago. And one of my favorites, I'll show here in a moment, only cost me $100. So Hamfest are a great place to go. We've got eBay, of course, QTH.com, and some others. And almost my entire lab that's been upgraded about every 10 years. And you say, well, why in the world did I do that? The receivers have gotten so much better every decade, but the test equipment had to get better. So there's a picture of my Denver lab. You do not need all that stuff, but I make use of it. So you don't be overwhelmed and say, well, I'm not going to do that. So here's my favorite little scope that's kind of obsolete, I suppose. It could be 30 years old, but it's a Tektronix digital storage, and when you poke it into storage mode, and it's got a CRT, which of course current equipment has an LCD, but it only costs $100 to go to eBay to buy it, like last week when I was checking prices. So I want to look at my signal just like you would with the old Heathkit or the Kenwood monitor scope, and we'll show you how to get a sampler. And one of our guests here, Tom W0IVJ, builds these things, and so other ones available in the commercial market. So you need to be able to get a signal from your feed line to the scope, and we'll talk about that detail in a moment. But here's what I do, and I have a scope at every operating position, or one I can see from either operating position. And so I'll do key down at whatever the rated power of my amplifier is, whether it's a kilowatt or 1.5 kilowatts, and I'll set it for like 6.5 divisions. So this screen will go plus or minus 4. So I'll go over 6 total. And then when I go to sideband, that's key down on CW. And then I go to sideband and I have to back off the drive so that I never go over the 6 divisions. And then I know I'm not clipping my linear because I just do not want to splatter. I don't know how you set it without a visual way to do it. And so this is important from a be a good neighbor standpoint, because we share the bands, and if you're splattering, we don't want to do that. You can do other things with this $100 scope. For instance, latency is an interesting subject in that a purely analog radio that maybe came out 30 years ago, the latency, that means how long does it take from a signal to come in the antenna for the sound to come out the speaker or your headphones. It might be 2 milliseconds, which hardly matters at all. It really matters zero. But then here's the Flex 6600 at its default filter setting, and it's 105 milliseconds. And if you set it up for the best shape factor, well, the delay is 170 milliseconds. Now that's a long time. So here, this little $100 scope. Now I did need a pulse generator. That was something separate that might cost $100. And you could make these kind of measurements with something that doesn't cost a fortune. So from a CW standpoint, we don't want to be having bad key clicks. And a lot of the equipment today has a menu that lets you adjust the rise time of the CW signal. If you go back 30 or 40 years, you had no adjustment. But today it's not uncommon. But sometimes the OEM, the original equipment manufacturer, gives you choices that are just absolutely terrible. You know, like a 1 millisecond or 2 milliseconds is a key click special. So this is what your signal would look like if you wanted to capture a single DIT, and with that $100 scope. And it's how quickly the signal goes from no signal to maximum output, like 100 watts. And the quicker it ramps up, the more key clicks you have. So on the left, that was 3 milliseconds. On a 10 tech, that's a little bit too fast. I like 6. So I'd say anytime you've got a choice, pick 6. Maybe 8, but definitely don't pick 1, 2, or 3, or even 4. But over on the right, that was as slow as this 10 tech would go, and that's 10 milliseconds. That might be a bit soft, but this is why it's nice to have an idea. What's your rig doing? One OEM told me, why do I care? And I said, well, your rise time is 1.4 milliseconds. And he said, what's wrong with that? Oh, terrible key click. So you don't want to do that. But here's a more modern scope. Now I bought it used, 10 years ago, maybe, on eBay. And it's a digital scope, but it's got a LCD screen instead of a CRT. And it's, in this case, it's just a 60 megahertz. But there is, of course, new equipment out of China that's probably even cheaper than this. So a lot of chances to get a reasonable scope, 100 megahertz, it would probably be where to shoot for. This one is just 60. So you say, where did I put this scope? Well, if you look at this, is operating position number 3. So to the left of the speaker is that LCD scope, that's the Tektronix, and I'm monitoring my signal. If you look closely, up on the 2 watt meters are sitting on top of the amplifier. There's something going on there. We'll get a close-up of that. So Tom W0IVJ built that, and that samples the signal to go to the scope. Now you also might say, well, why in the world do I have 2 watt meters in series? That's overkill, or that's a techie nerd like I am. One of the bird slugs is pointing forward, and one is a much lower power pointing reverse. So I happen to like that, but don't feel you have to do that. Now here's something that's probably out of China. 4 channels, 100 megahertz, and this is the newer stuff that I don't own anything like this. Be nice to have this. So there's just so many choices out here for reasonable choices that the prices that are not going to break the bank. So here's this sampler that Tom built for me, and he built another one for another operating position. Now you've got to have some skills to, from a mechanical standpoint. And so this is a 40 dB sampler, meaning the signal coming out the port there with the 90-degree B and C connector is 40 dB weaker than what's going out to the antenna. And so that little coax there goes off to the scope. If you want to look at this in more detail, the current 2022 ARRL handbook on page 25.58 has Tom's article on building the samplers. But maybe you just want to buy one. Tyler is here in Colorado in Loveland, KA0KA, and he sells this cute little box. It's got normal SO239 type of connectors on it, variable level adjustment to feed your scope, and then the sampled output. is a BNC connector, which most of your scopes are going to be BNC. So this works, probably is going to work on 630 meters. It's only rated at 500 kilohertz, but 475 shouldn't be a problem. And it goes up through 6 meters. It's rated for a legal limit, and it's only a little over $100. So options for checking your antenna. I mean, I realize your antenna never is going to fail, but maybe if it does, you'd like to have an idea of what's really going on. So it's handy to have a power meter that can measure forward power and reflected power. I like a scope for looking at, be sure I'm clean and I'm not flat topping, but there are peak reading watt meters. I've not had great success. I've had a couple of them that seems like they don't ever quite catch up, but some probably work better than others. I'll show a picture of one that I'm currently using that samples at like 4,000 samples a second. So it seems to do quite well. Probably most of you have heard of the MFJ 259B. I think I bought that 20 years ago. Don't even remember what it cost 20 years ago. The Nano VNA, that's something I happen to have. I've not learned to use it yet, but it can look at, SWR, can look at Smith chart type of pattern. It can do time domain reflectometry, which I'll talk about in a little bit later. And Tom, who's joined us tonight, if anyone does have questions about VNAs, he'll be the man to talk about it. And they're available from several sources. So apparently there's one that is kind of the originator, and then there's some carbon copies. And I guess there's minor variations there. Also, Array Solutions has some VNAs that are like $1,000. So probably not too many of us own one of those, but I know my friends here in Colorado, a couple will have them. So it's quite a tool. So there's a picture of the 259B. I've used it to adjust mobile antennas, to be sure that my beam resonant frequency is where it seems to be. It doesn't cover clear down into the new ham bands, but it's still a workhorse. They're available in the used market for 150 and up. The current model is a 259 Delta, 259D. I'd heard of the 259C, and there I went to look at it. Why, good, there's a new model out, but it's kind of pricey, $350. And it covers the new 2,200 meter band, the 630 meter band, clear up to the 222 megahertz ham band. Now, I've been making antenna measurements for many, many years, clear back in the 70s. And so there in the right-hand corner is what I've used many times to measure vertical antennas, like inverted L's, Marconi T's. And so the one thing to watch out for with these, like the 259B, is you hook it up to a big wire antenna, an inverted L for 80 meters or inverted L for 160. Static can zap this little 259B. So you really should discharge the antenna first. But now if you're looking at a beam, I haven't ever had a problem like that as far as static buildup that's going to probably zap the meter. But this old-fashioned general radio, it doesn't care. And it also deals with, if you're like on 160, the broadcast signals being picked up are just, 10 times stronger than what you're trying to measure. So this general radio can do a good job for that. But I doubt you're going to want to buy that either. But look how big it is. It's got a handle on the side. So here's this Nano VNA. You can see the funny circles that are, that's part of the Smith chart. And so if you guys have questions about it, we can get answers from Tom. There's the peak reading watt meter that I'm currently using besides regular wattage, key down or sideband or whatever. And it does cover the two new ham bands below the broadcast band. It's only rated up through 10 meters, although it does read on 6 meters, but it may be off a bit. But it samples at 4,000 times a second, so it really does catch the peaks well. I still prefer the scope, but if you want something smaller and simpler to use, certainly it's something like this. And there's other brands out there, the LP700, the LP500, etc. Here's, I'd say, the bargain of the century is an old Drake watt meter. I think they're around every kind of ham fest. I've got 3 of them at least. They're really handy. They don't show SWR. They're just forward power and reverse power. So if you have a 100-watt rig, and you want the SWR low, you're going to want something like 5 or 6 watts return, you know, 5 or 10 watts reflected. But they're reliable. I'd say the accuracy is about 10%. So plenty good for what we need to do. And of course, it's got the 2 kilowatt scale. So it's a nice meter. One case I use them in 160 meters when I have to retune my Marconi T from, you know, like 1800 clear up to maybe 1870 in a CW contest. I drop off the linear. I use this to remotely adjust my L network back to low SWR. There's another pair of meters. Again, you don't need to have 2 of them, but on 630 meters, the rare times I'm using my amplifier, I've got one slug that's a kilowatt forward power and then a lower power slug, the reverse. But the thing is with the birds, while the meters themselves in the used market are about $200, the HF slugs are kind of $100 or maybe $125. But if you're into VHF, you want a 6 meter slug or a 2 meter slug or 1296 slug at the Hamvention, Dayton Hamvention. It was in Xenia just a few weeks ago. There were all sorts of slugs available for a VHF and UHF for about $50. So if you really want to be able to measure for the VHF and UHF guys, this is a really good way to go about it. Power supplies, we say, okay, there's basically 2 types, linear supplies and switching power supplies. They both work. Depending on where your antenna is, you may pick up birdies from a switching power supply, but if your antennas are out in the field like mine, I've never heard that. But what I did run portable one time in Corpus Christi, and the antenna was a buddy pole just outside the window, well, the switching power supply made birdies. But I suggest that you should consider buying the ones that have meters. Now, they're not like 1% accurate, but when something started to go wrong, I had a 2 meter rig was having problems, and every once in a while it would blow the fuse. But once I was looking at the ammeter and I go key down to like 100 watts, the current kept creeping up. And so it's nice to know the current is reasonable or not, that the voltage is around 14 volts or not. So I just recommend if you are going to buy a new meter, a new power supply or one at a Hamfest, consider getting the ones with the meters. The switchers always have fans, whether like the ones that came from ICOM that are the PS 125 or 126, the fan cycle on and off. This Astron, the fan cycles on and off. Personally, I don't like noise, so I'm running my shack with the linear supplies, but they hum a little bit. So maybe it's a trade-off. Depends how much noise bothers you. Well, you certainly need some sort of a voltmeter. I'd hope you'd have a scope, and that would be something to consider if you don't. And definitely we need a voltmeter. Now, back when I was in high school, we had a VTVM that belonged to my dad. I don't even know if anybody's vacuum tube voltmeter still works, but if they do, great. I have a VOM, a triplet 630 NA, and of course the Simpson 260 was really popular. Nothing wrong with that. But you know, the handheld digital meters today aren't that expensive. I've even got a Radio Shack one. I think it cost me $75. And then some others like Fluke. And then a bench DVM that's probably not practical to buy for just general ham use. So there's a Fluke. I kind of recommend that brand. I bought this for $100. I think I actually bought this one in QTH.com. And it's just been a little workhorse. It's got a great big display, and you've got a diode check and a continuity thing if you're looking for open or short on a piece of coax or something. So a lot of features for not much money. It's not true RMS, but I doubt there's hardly anything that you need true RMS for. You'll pay maybe twice as much. Now, this is the used price. The new ones are maybe like $400 or $500, but there are lots of ones around that are on the used market, and I've never had a bad one yet. There's my lab voltmeter at my contest station. I'd say it's overkill, but it intrigued me to have something that was really accurate. So anyway, I've got one of those. You know me, test equipment out the kazoo, as you saw in the rack. Yeah, what's the difference between a soldering pencil and a soldering station? Well, I've had a soldering pencil forever, and one time I knocked it off the workbench and grabbed it as it was falling down and grabbed the hot end. It was pretty stupid, but it just was what it was. It only had one size tip and it was one temperature, and it wasn't even a constant temperature, particularly if you're trying to solder something maybe on a ground plane. So here's a picture of a Weller, and it's got an LCD, and you can adjust the temperature. Now, the one I happen to own, I bought like 4 of these that are the Metcal, and some friends of mine that worked at Hewlett Packard said the Metcal is the way to go, so I bought one for like $100 or 125. And it heats up like in seconds. And the way that you adjust the temperature is change the tip. So if you look at the little handle thing there and the tip sticking out, it just pull it out and put in a different tip that's got a smaller tip or a bigger tip. I have a tip or two that's like, it's not quite of a 1/4 of an inch, but it's really great if you're trying to solder to a ground plane, or maybe even you've got a chassis and you're trying to make a solder connection to it. So this allows you to change tips and do whatever you need, whether you're doing a little microfine stuff or something that's big and heavy and it's going to suck up all the heat. So I've had this model for years and I've never had a problem with it. So they use a Curie temperature. So it heats up like super fast because it goes up to the design temperature, and then the Curie temperature changes the conductivity, and then it stays stable at that temperature. Everyone should have a dummy load. Now, we go back in time. I've got a Heathkit Cantenna, and that's okay. And you didn't want to run a kilowatt into it indefinitely, but it worked for a few minutes. But today, there's so many dummy loads available, particularly for 100 watts. They're good to a gigahertz. So, if you're on 6 meters or 2 meters or 70 centimeters, and you aren't even hardly pushing its limits. These are available at Hamfest, on eBay, QTH.com for a reasonable price. And they come from retired cell site equipment. It looks like they must refurbish them, and then all these things go away, like GPS receivers and dummy loads and things like that. But if your transceiver is not working right, the first thing to do is hook it up to a dummy load. And it'd be nice that it was a really accurate one. Now, if you're going to buy a used one at a Hamfest, maybe bring your voltmeter along in your ohm meter and be sure it reads about 50 ohms, that somebody didn't put 500 watts into a 100 watt dummy load. But I haven't seen that actually happen. There's also the possibility, if you're going to go a little bit further and you're going to want to measure things on a scope or a spectrum analyzer or a digital receiver like an Apache or a Flex or something like that, consider an attenuator, and I'll show you a picture of that in a moment, that they're available easily for 100 watts or 150 watts and a 30 dB attenuator. And then if you were going to feed it into your scope, you might add some additional attenuation, but be like at the half a watt level. The attenuator doesn't even have to be terminated on the other end with a 50 ohm, because with a 30 dB attenuation, what's called the return loss is like 60 dB. So it'll work just fine as a dummy load, or if you want to use it as an attenuator. So it's more complex, but more versatile if you go the next step at measuring things like transmit intermod, CW rise time, like you saw with the Tektronix scope, or transmit noise. That's one thing that is very much different from one rig to the next, and it also at different spacings from the carrier. So it's interesting to, if you really get into measuring things, to consider using an attenuator instead of buying just the dummy load. So here's a Narda 30 dB, 150 watt attenuator. I've got one in Denver and I've got one at my contest station, and it's good to 6 gigahertz. It was $120. And if you look at the little red thing in a graph, you can see that once we get to 4 gigahertz, it has a correction factor of a fraction of a dB. And then we go to 6 gigahertz, it's in the opposite direction. So you can see these things are just amazing as far as being used. Any frequency you're probably ever going to operate, this thing would work as a dummy load or as attenuator. Like I say, they're available on eBay, Hamfest, QTH.com. So this is an attenuator, just looking at the same one from the side. You see it's got an in and an out. Usually for the ones that are 100 watts or 150 watts or even lower, I've got some 20 watt ones, some 50 watt ones. It doesn't matter which is in and out, it's the same. But once you get into the higher power ones, that's not the case. and you really need to be careful. So here, for instance, is a Bird 500 watt attenuator, 30 dB. You can see right there in the front, right below the nameplate, says input, and the opposite end says output. And you do not want to hook that up backwards. Now, if you've got a KPA 500 or approximately a 500 watt linear, this would be perfect for doing any kind of exotic testing you wanted. But if you're going to be testing a legal limit amp or even a kilowatt amp, don't use this one. Luckily, my friend Ken, N0QO, who we collaborate on a lot of testing, he's got the 2000 watt version, and it's like 2000 and up in dollars. I've seen them as high as $3,500. So you're probably not going to buy that. Luckily, my friend has one. This one, I paid $300 for it, and it arrived with good condition. Thank goodness, because it's kind of heavy. So there's your ubiquitous 100 watt dummy load that came out of a cell site, and it's like 50 bucks. So your next Hamfest, pick one up. Lots of different brands. This happens to be a Bird. The ones I have, that was a picture I got off the web, but I've got different brands, or didn't even know who the brand was, but they all work tremendously. Again, the attenuator is more versatile, but just you need a dummy load you can totally trust. For 50 bucks, you can't go wrong. Signal generator. Now this is where it gets dicey depending on what you're going to want to do. As if cost was no object, well, no problem. But let's say you've got a problem with your transceiver and you're not really sure what's going on. Matter of fact, right now, there's this discussion going on the K4 reflector about a receiver that's acting funny on some frequencies. And so there's actually a little device from Elecraft, this XG3. If this person had it, he could maybe figure out what's going on to see, is it something wrong with the firmware, something wrong with hardware. So it's really nice to be able to do some basic checking. But we need a wide range attenuator because some signals are, less than a microvolt, and some signals are going to be like S9 plus 40s minus 33 dBm. So we need to have an idea what's going on with our radio if it's sort of acting up. The other problem is if you did really want to measure sensitivity, MDS, that stands for minimum discernible signal. That isn't really reality. You can hear below MDS, but that's what it's called. That's where the signal equals the noise floor of the receiver. So it's nice to have something to make a measurement so you can, okay, the radio is working great, my antenna's got a problem, or maybe it goes back to the factory. So the Elecraft, I'll show a picture of that. There's a rather inexpensive signal generator coming out of China. Well, just consider it puts out a signal. You're really not going to probably know what the level is. It goes down to DC, so you can use it as an audio generator, clear up to the 6 meter band. And then there's the HP 8657B, and there are zillions of them made, so they're on the used market. So here's the little Elecraft XG3. Now it's not real cheap. You can buy it from DX Engineering, or you can probably buy it from Elecraft Direct. It's got the ability to put out a signal on 160 meters through 2 meters at 4 different levels. So I say 1 microvolt. That's a nice level because most receivers today that have switchable preamps, if you have the preamp off, probably 1 microvolt is below the AGC threshold. Minus 73 dBm, that's nominal S9 sometimes. That was supposedly the Collins standard, but when I had an S9, it wasn't minus 73. With ICOM, S970 minus 73 dBm. But with Kenwood, it's minus 73 dBm is S9 with the preamp on. Now, why that is crazy. We ought to have standards that S9 is minus 73 dBm or 50 microvolts. No preamp, that should be the standard. And minus 33 dBm, as I mentioned a bit ago, that's S9 plus 40. So if your S meter is working right and your receiver seems to be working properly, well, it'd be interesting to see at least that S9's right and 40 over 9's right. And then you've got an output there of 0 dBm for some other measurements. Here's this really inexpensive little generator. It goes up to 60 megahertz. It goes clear down to DC. It's got adjustable output, but it's not real accurate. But it's for a modest price, at least you have some way to produce a signal or maybe an audio source. So anyway, it's something like this, come out of China and they're not bad. Here's this HP. There were thousands of them made. And I thought, well, if I'm really going to recommend one, I should buy one. So I bought one about 2 weeks ago on eBay. It was $500. And that may be more than you want to spend, but it's something that's solid state, pretty reliable, good for general testing. Not really good for the absolute state-of-the-art dynamic range measurements. And I'll show you why in a moment. But look at the range, 100 kilohertz to 2 gigahertz. It can go up to plus 13 dBm, which is a pretty strong signal, down to a level that I scratch my head on, minus 143.5 dBm. When you're making noise floor measurements, once you get below about minus 135, which is not unusual for our current radios, or even way back in time, you're kind of getting into the ozone. Leakage can be a problem out of the the case getting out somewhere besides the connector on the right. Your coax needs to be really good coax if you're going down below like minus 135. And if you're on 70 centimeters, you better have the best double shielded cable commercially made with end connectors on it, probably an adapter at the back of the radio, although maybe for 70 centimeters, it's got an end connector, my ICOM does. So just sort of consider, well, where are we in the ozone? And I'd say at minus 143.5, we are. Matter of fact, it's a bit of a, I have to admit, there's one Collins 75S3B on my website that goes clear back 40 plus years ago, and it says minus 146. I imagine that's wrong. I probably had an HP 606A tube type signal generator. Who knows what the leakage was, but if I knew who's had that radio, could borrow it again today, 40 years ago, it's probably not that. But the 75S3C that I own, it says it was minus 141. And that seems to be a reasonable answer. But, when you're really at the low end of the scale, just realize that you're not like accurate within a half a dB, believe me. Here's the signal generator that I use all the time. I've got 4 of them, 2 at each QTH. And this is what I have today to measure today's equipment. The today's equipment is astounding. For a long time, for like decades, once we had synthesized receivers, the phase noise was terrible. And the dynamic range of the radio wasn't limited by third order dynamic range, but by phase noise in the receiver. So, but as I've said, about every 10 years, I had to upgrade the test equipment because the receivers got better. And now lately, Kenwood, Yaesu, ICOM, Flex, Apache, these radios have amazingly low phase noise. So you cannot just use your garden variety signal generator to test it like that $500 one with the green display. But this guy's kind of hard to keep working. The light bulbs burn out on its LCD to screen, which is really annoying. But this is what's required to test the state of the art today. We just have astounding equipment today. So to show you the difference, that you're probably not going to want to have to do this, but here's 2 signal generators fed in. One was the one with the green display that's $500, and one with the orange display that costs more than that. And this is a spectrum analyzer. Now, if you look at the baseline, clear down 100 dB down, you see noise. That's the noise of the spectrum analyzer. But you can see these 2 signals. One was the A channel and the B channel, and then I just summed them. You can see, look at this one, look at 9 divisions down from the top, or 1 division up from the bottom, at an offset there of about 1 kilohertz or 2 kilohertz. Look at the difference in the noise from the generator itself. The one that's widening out and looks noisy, that's the $500 one, the 8657B. But then the one that had the orange displays, you can see it at 1 kilohertz offset, it still doesn't show noise. So that's what's really tough today. So whether it's the league or RSGB or myself or Adam Farson, we really are pressed on having equipment good enough to measure our current equipment. So we're just about wrapped up here. Time domain reflectometer. Now you can measure that with that VNA. I use a Tektronix that is just a time domain reflectometer, and say, what the heck is that and why would I want it? Well, maybe if you've just got one antenna with a tribander and a piece of coax, probably not much of a big deal. But the more complex your station is with hardline, you have to have a jumper, RG8 or RG213 or something probably running into the shack. Certainly at the top of the tower, because of your rotator, you've got to have transition from like hardline to coax. And every time you've got a connector, you've got a potential problem. So 2 times in the last like 3 years, something was wrong. I had one case, I had a short on the 40-meter beam and it came and went. And in the other case, I had an open on the 10-meter beam. So this TDR, time domain reflectometer, I could measure where was it happening. Did I hit a piece of hardline with the lawnmower? Was the problem just outside the shack when it went from RG213 to hardline? Was the problem at the top of the tower when I went from hardline to flexible coax so the rotator could go around? And it just saved me completely because I didn't have to guess where the problem was. So that's a bit esoteric, but if you've got an open or a short or something, it's really good to be able to find out where is it without worrying about, is it 100 feet away, 200 feet away? In my case, 270 feet of coax up the tower at 70 feet. So here was the little TDR that I bought. I bought it 10 years ago in Fort Collins. I paid $300, but you can buy them today. It's it's many years old for like 150. Again, if you just got a one or two antennas, maybe not worth worrying about. But if you've got a lot of connectors and coax and hardline and all that, it may really come in handy. Spectrum analyzer, that's in the frequency domain as opposed to the time domain. When you saw the CW DIT, that was in the time domain. But if you're going to look at distortion products or noise, well, then you're looking for a spectrum analyzer as opposed to just a normal scope. And there's swept analyzers and fast Fourier transform analyzers. But your SDR radio might be a really good spectrum analyzer. I mean, really, if you've got these direct sampling radios and you see a signal that's wide, believe me, it's wide. I mean, you might join the QSO and say, ham W1XYZ, your signal's wide. In the old days, the guy would likely say, I'm overloading your receiver, I'm not wide. But if you see it on a current direct sampling rig, whatever you see, that's reality. So this is a swept spectrum analyzer. This happens to be the distortion products of a Collins 32S3. That's the cleanest sideband transceiver or transmitter in this case I've ever owned. And you could just measure the distortion products. You put one dot on one of the 2 tones. I mean, it's a 2-tone test. The 2 tones are equal. And then you just put the other cursor on whichever of these blips you want to measure. So in this case, it was on the 3rd order. You look in the right-hand corner at the top, minus 36.5. Now that isn't the number that would be published though in a magazine or in an ad, because for some reason, people like bigger numbers, even though the bigger number is not any better than the lower number. But so if you see something in QST or RSGB or whatever, they're going to add 6 dB to it called the PEP, peak envelope power meter reading, but it didn't change the distortion product. So this, if we were going to publish it, it would say minus 42.5, which of course would be tremendous. So that's just an example of what you can measure. And some of the rigs have a built-in tone generator, so you don't even have to do that. The K3, the K4, at least I know they would have the tone generator built in. Maybe the Apache, I'm not sure. So there were the spectrum analyzers I was using. And again, they're available in the used market for 10 cents on the dollar. Here's my favorite little fast Fourier transform receiver, but I use it for a spectrum analyzer. It came out a long time ago. It's still top of the line as far as measuring things if you really want to look at distortion and noise and things like that. And the amazing thing was when I got my ICOM 9700, which covers 2 meters, 70 centimeters, and 23 centimeters, I was wondering, well, how good is the phase noise? And so, of course, this is a receiver that only goes up to 40 megahertz, but I was able to mix down 2 meters, 70 centimeters, and 23 centimeters to 20 meters using that signal generator that had the orange display and a plus 17 dBm mini circuits mixer, and right into with attenuation too, of course, into the Perseus, and make measurements that I was lucky that a friend of mine from Europe has access from his work to a $150,000 piece of test equipment that measures all sorts of noise, amplitude noise, phase noise, composite noise. And his measurements on the ICOM transceiver, the 9700, were within 1 dB of what I measured with this little receiver that you can buy brand new for $770 at HRO. So if you really are getting into making measurements, this is an amazing piece of equipment. This is what this software looks like. So you can measure on frequency, off frequency, whatever. So Tom, W0IVJ, did a screenshot for me for what you might, if say you were going to measure noise from a signal source. You in his case, he used a 10 megahertz and a 10 megahertz filter and then offset it 5 kilohertz. And you can see that the signal source has noise on it. Well, one of the older generators from HP was the 8640B. There must have been, who knows, 50,000 of them made. And here's what it looked like, that you could barely see the noise on the, this is the phase noise at 5 kilohertz offset versus that $120 source, signal source that I saved. It's not going to do everything you want, but if you just need something, $120, it wasn't bad. So there we have the extent of my chat today. And if we have any kind, I'm going to stop sharing here in a moment if I can find it. Where to go? So can you stop sharing it for me? Is anybody there?
Yeah, I'll stop it.
Okay, good. So for some reason I lost it.
Yeah, no. And are there questions for Rob?
Well, I've got some comments.
Sure, shoot.
Okay. I don't know if you have even heard of this or not. It was a chief engineer at the local television station that showed me this. He picked up my Bird 43 and he said, you shouldn't store that thing turned one way or the other. And he waved it around in midair and the needle flew all over the place. And then he put the needle, slug, turned the slug to the up and down position, and the needle didn't move anymore. He says, you realize how expensive those meters is? Do you realize how sensitive they are? And that's the Earth's magnetic field messing with that thing. It's really amazing when I saw that. So good idea if you're just intermittently using a bird meter to store it with the slug in the 90-degree out of position range.
It might also be shorting the meter, don't you think?
I wouldn't know.
Anyway, good advice. Whether it's shorting the meter, that would be my guess. But in any case, sounds like absolutely sound advice.
Okay, the other thing I wanted to mention was I didn't realize this till 3 years ago. VHF UHF S9 is not minus 73 dB. It's
right.
minus 60 something.
Well, it's fine.
Why they did that, but
right. It's 5 microvolts instead of 50. You're right. And I don't know why they did that. The ICOM R9000 doesn't do that, but I think every VHF rig that I've had is absolutely not 50 microvolts. It's a tenth of that.
Okay. The other thing I did want to mention is I want to give Tom a little pat in the back. He developed a circuit a while back for peak reading devices. I think he actually developed it for his amplifier. And I got my hands on that circuit, laid out a circuit board with a couple holes on it to fit a typical meter. And you can convert a like your W4 watt meter, you convert that thing into a peak reading meter very nicely. And if anybody's interested, I haven't had any of those boards printed out in years. But basically what it's got is, Tom should talk about this, not me. But basically it's got a microprocessor, not a microprocessor. What am I trying to say? Shoot, I hate it when I skip a word. But at any rate, what it basically does is looks at the peak value and holds it long enough to bring the meter up to that value. So it's not just recalibrating an ordinary analog meter to tell you the peak reading. It actually is getting the peak meter, the peak value. And it worked very well. I've used it on several things. And if anybody's interested, I can go dig out that circuit and get some of those little circuit boards made up again. But you probably ought to get Tom to say something about that here.
Yeah, go ahead, Tom.
Well, it just has a couple of op amps in it, and in the diode detector, and it adjusts the impedances so that the diode detector is looking into a high impedance, and it has an RC time constant that you adjust, and it holds the peak long enough for a regular meter to reasonably display that.
Yeah, that's all I had. Thank you for the presentation. Very nice,
Rob, have you experimented at all with the Regal spectrum analyzers, the 800 series stuff?
I haven't, but there are some here in Colorado. Tom, does Larry have one?
I don't think he has the spectrum analyzer. He has the scope, but I don't think he has a spectrum analyzer.
So I think between Regal and is it Signet or something? Pretty decent equipment, aren't they?
The one I have, the 815 Regal, is a whole lot of equipment for not a lot of money.
What's the approximate cost?
I think it was about $1,500, something like that.
I mean, the one downside of all my 30-year-old equipment that replaced 60-year-old equipment a long time ago is keeping it working. So there would be the upside of the more modern stuff. Hopefully a lot, failure rate is pretty low.
One thing I would mention is that if you could build a little crystal oscillator and then have a good attenuator, then you can get things down to the minus 130 dBm level with an attenuator. And you can do that in 1 dB steps or 10 dB steps if you get one of the good HP attenuators at a Hamfest.
Yeah, the 355s, C and D are a bargain if you've got one in good shape.
Thank you.
So I'm curious, does anyone notice they've had questioning is my transceiver working right or is something wrong? We don't have to align the current stuff. You know, the Drakes and the Collins, we had all these alignments to worry about. That's gone. So how typical of any of you on the Zoom session here have had a question like, is my transceiver really working right? And but I wish I had some way to check it out, or is it really not been an issue?
I can make a comment.
Sure.
I have 3 stations. Every single one of them has a YO100 on it. So between what I hear and what I see on that YO100, I'm confident I'm done.
You want to explain what the YO100 is?
It's a monitor scope. It's you know, monitoring the output of the transceiver versus the output of the amplifier.
Is that the Heathkit, Ed?
No, that's what Yaesu.
Oh, it's a
Yaesu
Yaesu,
made it.
okay.
Made the YO100. And the one thing about that one is that particular model clamps so that you can leave it turned on. It isn't just sitting there burning a hole in the screen when you're not talking. But for the life of me, I think there's a possibility out there someplace for some software people and Tom's sensors, which are fun to build. I built several of them to take that output somehow or another to a device and subsequently to a computer, and we can start having some modern day station monitors with the trap patterns and all. Are you able to do a trap pattern with your with the way you're set up, Rob?
No, but that device from KA0KA, it can do a trapezoid.
I'll have to look into that.
But you have to have an external scope to do that, right?
Sure, right.
Yeah.
Yeah, I'd like to, everybody's got a computer running in their station. I'd like to see it on fed to a USB port. Of course, I'm a daydreamer.
Well, Ted, you probably could comment on how to do that.
Well, you know, the YO100's got a couple of 12AX7s in there. I'd probably start with Zener stabilizing the heater voltage.
Well, that, you know, the sampler, some of the linear amplifiers today come with a sampler. But right now, Apache is the only company that offers pre-distortion, which is a way to linearize not only the exciter, but your external amplifier. So the newer 1000 watt legal limit amps have a sampler built in, and then that of course could go back in the radio if we ever have either Flex or Elecraft offer that feature. But in the meantime, you can feed it to your scope. It's something I talk about in that others probably did a year ago or less than a year ago, that we've got the capability in the modern rigs that particularly that talk to a computer as opposed to just a standalone box. But then Elecraft says they'll offer this feature. Now, of course, until we see it, it doesn't exist. I know Flex has been playing with it for a while. And so their amplifier has a sample port. I know the Hilberling out of Germany has a sample port. Some of the others do. So, and if you got an L4B or you got an SB220, you put one of those samplers on the output, and maybe we'll have more stations to be able to run pre-distortion for a cleaner signal. And boy, the difference is night and day. Tom, talk about our 75 meter group, how different the signals are.
Yeah, well, our 75 meter group has the capability of the signals are strong with respect to the band noise, even in an urban location like I have. And I'm the only one that has pure signal. But when I switch the pure signal on and off, it makes a 15 to 25 dB difference in the third order products.
And Tom's signal on the waterfall just looks like a rectangle straight up and down. And unfortunately, mine doesn't look that way. And the other hams in our typical morning chat don't look that way either.
The Annan radio, you can easily adjust that transmitter for a perfectly square or triangle shaped transmitter with anybody's voice. It is absolutely amazing.
Yeah, that's what I have as an Anon 7000 DLE. So
that's what I have as well. Yes.
Yeah.
So isn't competition great? Because if now we can get people to really care and say, I want to clean your signal too. And if we could have 3 companies producing rigs that can do pre-distortion by whatever name they want to call it, wouldn't that be great? And maybe we could get the 3 companies out of Japan to come along too. But keep our fingers crossed.
Well, I was listening to a QSO even today, and the guy was saying, oh, with that pure signal, you can really have a clean signal. And the other guy's comment is, you don't want that, people will move in on you. So what do you say?
Get a bigger antenna.
Bigger amplifier.
The serious argument for key clicks.
Say that again.
I said it's a serious argument for key clicks. You can just kind of spread folks away from you.
Well,
Works
one
in
thing.
contests.
One thing at Contest University that Tim Duffy runs, that is the starting point for the day is we share the bands. We should have a clean signal as possible. And that would be the absolute worst thing to do is to be on purpose be wide, whether it's CW or sideband, that just doesn't cut it. But unfortunately, we have to deal with those who don't care.
Well, and when we could talk about cut numbers and things like that, but we won't.
But you know, the really bad signals are probably flat topping their amplifier. I mean, there's variations in rigs, and obviously the Prior signal is astounding. But when somebody's like certainly you've probably all seen on the air that's 20 kilohertz wide, that's not his rig unless it's broken. That's a case where he hasn't a clue, hopefully, that he's driving his amplifier into saturation.
Rob, I don't know if you've got into any amplifier specs, but isn't it a pretty well known fact that transistor solid state amplifiers up until just recently, and I mean the last few years, generally if they're driven at over 50%, they start distorting very badly?
I would say anything solid state on the market right now is 10 to 20 dB worse than the better tube amps. That information comes from the ARRL. They put out a compendium of data on tube amps in 1997. And then you compared it to the LD-MOS amps, and almost everyone's running LD-MOS. There's some older ones that are bipolar. But let's just talk about the typical LD-MOS like a KPA 1500 or the Power Genius or whatever. And they're going to be 10 or 20 dB worse than the best tube amps. And that's sad. Thank goodness pre-distortion can fix that. But since we only have one brand that does it currently, we're stuck with, it's convenient. You don't have to tune it. You don't have to switch bands. It just like having a kilowatt transceiver. But the trade-off is we're much wider than we were in the old days.
Yeah, Ed, I've got my amplifier is MOSFET instead of LD-MOS, and I think the MOSFET amplifiers were a little bit cleaner than the LD-MOS actually.
And the Yaesu Quadra, I think it's certainly not LD-MOS, and it's a little bit cleaner than all the LD-MOS amps except for 6 meters.
That's a MOSFET amplifier. I think it has 8 MRF 150s in it.
Oh, by the way, since your mobile antenna was shared earlier, and a question was asked, did you do the machining or did someone else do the machining for you?
I did the machining on that, but I don't have access to that equipment since I retired.
Well, anyway, everyone was complimentary on your antenna. Is cool. And it works really well.
Bob, I have a question about ALC. I've been a ham now for 63 years, so I recall when ALC was fundamentally something you did to bias off a grid or bias up a clamp tube or something like that. And it got kind of a bad rep for producing a lot of distortion. Now, modern radios don't do that. They turn the gain down. They don't just bias off a tube or something. Do you think ALC has gotten a lot better since the days of yore?
Well, first off, I only have tube amplifiers, and some of the, in my case, they're ACOM or they're alpha, but whatever they are, I never run ALC with a tube amp. I use my scope. I set it, as I mentioned, a little over 6 divisions key down, and then when I talk, I never let it go over 6 divisions by adjusting the drive level. So some of the solid state amps, like I know the PW1 really expects the ALC to be hooked up to your ICOM transceiver. I'm not sure what happens on another brand transceiver. It's not a particularly clean amplifier. So unless you're really trying to keep you from doing a terrible mistake and blowing up the amp, and maybe ALC would have something there, but still you've got a potential initial spike overshoot. So I don't know. I'm not an ALC fan. One of the local hams here that's 12.7 miles from me got a report of being wide. And so he was really concerned. And so he called me up and said, we got to do some testing. And so we got on 10 meters and 15 meters and pointed our 5-element Yagis at each other, and we were 30/9, but legal limit. And then we started listening. I started measuring his signal strength on the opposite sideband. And so he started out with an IC 7600, not a 7610, but a 7600 and a PW1. And the signal on the upper sideband was 30 over, and on the lower sideband was S8. And then we tried another rig and another amplifier, and he ended up with a 35-year-old ICOM, I think an IC 735, and a modified alpha that had 3CX 800s in it. And the distortion products on the opposite sideband went from S8 to S3 with the same legal limit output. So I would say our bigger problems are the distortion in the solid state amps. And I would just go by what the OEM recommends from an ALC standpoint, but with my tube amps, I never use it.
There's some new ways of doing ALC out there. I believe SPE doesn't just put a 1 in 34 and an attenuator on the SO239 coming out of the amplifier and feed it back to the radio. They actually send back a solid, hard voltage to reduce the drive without really trying to do it dynamically. And that seems to help a lot with both overshoot and other sorts of things like sneezing into the mic.
Is that all internal to the amp as opposed to feeding something back to the transceiver?
Well, they're feeding the signal back to the transceiver, the ALC signal back, but it isn't just sitting there being beat on by the modulation. They figured out what the right level should be and then reduced the amplifier drive via ALC to not exceed that.
That jogs my memory on something. ALC on the 32S3 had a very slow time constant. And it even had a meter that could show up to 20 dB of ALC. And it was really just a leveling circuit. It wasn't trying to do speech processing or make you louder. It was just going to try to be a leveling circuit. Well, the FTDX 5000 has a syllabic rate ALC, and it destroys the intermod, because I did measurements on that rig with no ALC and class A, and then like 3 dB of ALC in class A, and it destroyed class A. And I complained to the head guy at the Hamvention in Dayton. I said, you're ruining your class A, because I was on the air with this borrowed rig at one point running an Alpha 89, which has a pair of 3CX 800s. A guy broke in on frequency to my QSO and said, I want to comment on your signal. And I thought, uh-oh. And he said, I have a K3 and a P3, and that's the cleanest signal I've ever seen on the air. But if I was running 3 dB of ALC, it destroyed it. It was like 20 dB worse. So the person at the Dayton Hamvention for Yezu said, it makes us louder. Well, okay, it makes us louder, but it made us splatter. So the time constant really is important, and it really, ALC should only be a slow leveling circuit and not trying to follow every syllable.
That's kind of what SPE seems to be doing. And that brings up the question of when you're getting ALC, you're in the magic little red zone in your meter, and you should stay there because of distortion issues. How bad are the distortion issues? Don't modern radios just turn the gain down rather than trying to do something rude with the finals to make less power go out of it?
Well, I think ALC, like on a T4X or something or other, a Drake transmitter, went to the grid of the driver tube. So I think ALC always went back relatively early. Maybe we even went back or the stage before that. I don't really know, but I would think. Well, first off, there's variations in the voltage coming out of amplifiers, and what the transceiver is expecting. So there's not even a standard for that. I think even some amp puts out a positive ALC voltage, everybody else is negative. So it's kind of a can of worms.
That's rude. One shouldn't do positive voltage. But the question is more, when the ALC coming back to the radio starts to attenuate things, does that necessarily increase distortion from the exciter in modern radios? It certainly did in TR4s.
It did or did not in a TR4?
Did.
Okay. And there in the TR4 had a meter that showed the ALC when you're transmitting, so you could control that. I don't know. Does anyone want to chime in as far as I mean, I think it would really vary on each rig how it handled it. I mean, if it was slow, if it was a slow time constant, I don't see why it would cause distortion. If it's a syllabic rate, I think it almost by definition would cause distortion. What do you think, Tom?
I would think so. And before you started mentioning the that case that you had, I was going to ask Ted if the SPE had a slow time constant on the ALC, because it just seems to me like a slow time constant is going to be better than trying to adjust every syllable.
I think it's a really slow time constant. It figures out the amount of ALC feedback to the exciter that it needs, and then it parks it there without doing syllabic kind of stuff, which seems to be like an invitation for problems.
Yes.
You know, there's something that the Apache does, and maybe Tom can talk about it in more detail, that Warren NR0V has written that code, and the old-fashioned open loop ALC is almost a guarantee of some sort of overshoot, because the signal came out, it was too strong, a signal came back, turn it down, but it was too late, you know, almost by definition. But Warren looks ahead in these digital rigs, and so his ALC functions before the signal got too strong. And this is the way we all ought to be doing it with these, you know, digital rigs with ADCs and FPGAs and all that kind of stuff. Doing it the old way is kind of silly.
Testify. I'm on your side.
So we've got some, you know, clever programmers out there, and if we could get them to quit doing it, well, we've always done it this way, we keep doing it this way. Let's get some improvements.
Well, that brings up the S meter situation.
For sure. I mean, as the Apache and the Flex, and actually the TS890S in mode 2 mode gives you 6 dB per S unit, but all the Japanese rigs otherwise 3 dB per S unit. It makes band noise look lower, it makes QSB look worse, and then we can't even decide whether S9 is with the preamp on or off. It's just nutty.
It's not fair.
I had one guy, I gave him a signal report. He was not happy. He said, turn your preamp on. I turned my preamp on. The signal report was 10 dB stronger. That made him happy.
Well, on the Flex and on the Apache, it doesn't matter whether preamps or attenuators are on. The signal strength is measured right what's coming into the antenna port.
And the same with the K3 in absolute mode and a couple of the Ten-Tech rigs.
And the Perseus. Now the Perseus, the attenuator affects it.
No, I don't think so.
I'll have to check that out.
I think it's right. But with the processing power in radios today, there's no excuse for not having an S meter that's right. I mean, obviously the signal doesn't change when you turn the preamp on. It's whatever it is coming in the antenna lead.
But we still haven't solved the problem, because now we have antenna factored in there.
Well, right, sure. I mean, we don't have a reference antenna at everybody's QTH.
That's right.
599 OM.
Yeah, even if I take 5 times to get the call right, it's 599.
Right.
All right, gentlemen. Well, if your club has a second win, go for it. I think I'll say 73. Tom, thanks for your input. and enjoyed being a guest of your club for the second time.
Rob, we really appreciate the time and effort to put this program together, and it was, always timely and always topical and always spot on. So thanks an awful lot again.
And I'll send you a PDF of the last version, which was just updated over the weekend.
Oh, perfect. And we'll post that on our website so that folks will have it. Bob?
Yeah, I just want to mention something, by the way, Rob, thank you so much. It's a wonderful program and a great discussion tonight. But I noticed that there were about a half dozen people who joined us pretty late. So I just wanted to mention to them that you can see this program in its entirety in about a week or 10 days, I think, right, Kevin? And it'll be on our YouTube channel. If you go to our club's website, madisondxclub.org, it'll give you a link to our YouTube channel, and you'll be able to see the program in its entirety. Also, take a look around because there are some other great programs. Last I looked, we had about 19,000 views. So we're getting a pretty good response to that. Anyway, thanks so much, Rob.
Okay, bye-bye.